Air and water. Our atmosphere. Our Earth is the only planet that has life on it. Scientists are still exploring other planets, but nowhere else life has been found. Our Earth is surrounded by a blanket of air called the atmosphere. It extends for several hundred kilometers above the surface of the Earth and becomes thinner and thinner as we go up. When we go up high into the atmosphere, it becomes difficult to breathe due to lack of oxygen. That is why astronauts and mountaineers carry oxygen cylinders with them for breathing. Similarly, deep in the ocean too, oxygen is less. The oxygen in the atmosphere supports all life forms. The atmosphere contains carbon dioxide gas, which helps plants to make their food. Atmosphere protects the Earth from the harsh light and heat of the sun. It acts as an insulating layer and regulates the heat that enters the Earth. It also protects us from the falling meteors. Layers of the atmosphere. The atmosphere of the Earth is comprised of different layers based on the temperature variation. These layers are troposphere, stratosphere, mesosphere, ionosphere, and exosphere. Troposphere. This is the lowest part of the atmosphere, the part we live in. It contains most of our weather, clouds, rain, snow, etc. In this layer, the temperature gradually decreases as we go up by about 6.5 degrees Celsius per kilometer. The troposphere contains about 90% air of the atmosphere and almost all of the water vapor. The top of the troposphere is called tropopause. This separates the troposphere from stratosphere. It is about 7 to 10 kilometers thick at the poles above the Earth's surface and 17 to 18 kilometers near the equator. Stratosphere. This layer starts just above the troposphere and extends up to a height of 50 kilometers above the surface of the Earth. Compared to the troposphere, this part of the atmosphere is dry and less dense. The temperature in this layer increases gradually to -3 degrees Celsius. This layer is very important for us because it has a very important gas called ozone. It protects us from the harmful ultraviolet rays of the sun, which can even cause skin cancer. The top of the stratosphere is called stratopause. It separates the stratosphere from mesosphere. Mesosphere. This layer extends up to a height of 80 kilometers above the stratosphere. Mesosphere has the coldest temperature in the atmosphere. Ionosphere. The ionosphere starts at about 80 kilometers and extends up to nearly 400 kilometers above the Earth's surface. Temperature increases with the increase in height in this layer. Exosphere. The exosphere is the outermost layer of the Earth's atmosphere. It extends beyond 400 kilometers above the Earth's surface. Although its outer limit is not clearly known, but it is assumed to extend up to about 800 kilometers. Air. Air is a mixture of gases like nitrogen, oxygen, carbon dioxide, argon, hydrogen, etc. It has about 78% nitrogen, 21% oxygen, and remaining 1% is other gases, carbon dioxide, hydrogen, argon, helium, etc., whose proportion may vary according to weather and environmental conditions. Out of all these gases, oxygen is the most important gas as it is required by all living beings for breathing. Oxygen is also needed for burning. There is only 0.03% carbon dioxide in air. It is the gas that helps the plants to make their food by the process of photosynthesis. Living things cannot directly use the nitrogen present in the air. Plants absorb nitrogen from certain bacteria in the soil, and animals and humans get the nitrogen from plants or plant-eating animals. Neon is a colorless and odorless gas. It has a bright orange-red glow when placed in an electric field, so it is used in electric signboards. Argon is used in glass tubes to produce a violet-colored glow. Humidity. Water vapor is always present in the air. This comes from the water bodies like seas, lakes, and rivers, where evaporation takes place at the surface by the heat of the sun. Water vapor is responsible for the changes in weather. It can bring rain, clouds, fog, snow, or hail. Sometimes we feel sticky and our body sweats. This is because there is more water vapor in the air, which prevents our sweat from evaporating, and we say the humidity is high. Humidity can be defined as the amount of water vapor present in the air. Properties of air. Air occupies space. Air is everywhere around us. Although we do not see it, we can easily prove that air occupies space. Take a vessel full of water. Take an empty glass. Now, hold the glass upside down in such a way that its opening touches the water. Push the glass slowly into water without tilting it. We will see that water does not enter the glass. This happens because air present in the glass is unable to come out. So, water cannot enter the glass. Now, tilt the glass slowly in the water. We see the bubbles of air start coming out of the glass and water starts entering the glass. This happens because air comes out from the glass in the form of bubbles and allows water to enter the glass. This clearly shows that air occupies space. Air has weight. To prove that air has weight, take 2 empty bicycle tubes. Fill the air in one tube and experience the weight of both the tubes. We feel that the tube containing air is heavier. Thus, we can say that air has weight. We can do another experiment. Blow 2 balloons of the same size. Tie one balloon at each end of a stick. Now, tie the stick with a string at its center. Balance the stick by shifting the position of the balloons. As we hold the stick up by the string at its center, we see the stick remain straight. Now, prick one balloon with a needle to burst it. We see the end with burst balloon goes up. This happens because the burst balloon has no air in it and so it becomes lighter. This shows that air has weight. Air supports burning. Air is required for burning. The oxygen gas present in the air supports burning. In the absence of air, burning cannot take place. To prove this, take 2 candles and light them. Cover one of them with a glass. Within a few seconds, the candle burns off. This happens because the covered candle did not get air for burning. This shows that air is essential for burning. Air exerts pressure. To prove that air exerts pressure, take a cylindrical box with cap on one side. Make a few holes on its one side and 1 to 2 small holes on the cap. Now, fill half of the box with water and cover the cap. Now put your finger on the hole in the cap so that the holes can be covered properly. We see that water does not flow through the holes on the other end. Now, we remove our finger from the holes in the cap. We see that the water starts flowing through the holes. Because when we remove our finger from the holes, air trapped inside the box and exerts pressure on the surface of water, and thus water starts flowing from the other end. This shows that water exerts pressure. Uses of air pressure in our daily life. We know that air has pressure. When we go up high in the atmosphere, the air pressure decreases. The pressure of air is used in our life in many ways. It is used in medical syringe for filling ink in a pen, pumping air into a tube, and to drink cold drink using straw. It works in our body also as breathing controls the balance of air pressure inside our body. Air pollution. Smoke and harmful gases coming out from the vehicles, factories, burning of garbages and fossil fuels releases in the atmosphere and imbalance the quality of air. These impurities make the air polluted and causes various diseases in the human beings and animals. Polluted air is harmful for breathing. Air pollution can be controlled by afforestation. Water. Water is known as universal solvent. The solubility of a substance is defined as per its solubility in water. Nearly 71% portion of our earth is covered with water. It is available in various forms such as groundwater, underground water, seawater, glaciers, lakes, and water vapor. Water is present in the atmospheric air in the form of water vapor. Water dissolves sugar, salt, etc. in it. When we dissolve a substance in water, a solution is formed. The substance that dissolves is called the solute, and the water in which the substance dissolves is called the solvent. Substances which dissolve in water are called as soluble substances. Example, salt, sugar, etc. and those which do not dissolve in water are called as insoluble substances. Example, sand, chalk, etc. Rainwater dissolves many substances from the air or the ground. It also collects mud, dead vegetable matter like decayed leaves, germs, and other soluble and insoluble impurities. It also carries different minerals and salts in it. Impurities in water. Impurities are the substances such as dirt, sand, chemicals, and germs which make the water unfit for use. Impure water can cause many diseases because it contains harmful germs. So, impurities in water must be removed to make it fit for drinking. Impurities are of two types: insoluble impurities. Insoluble impurities are the impurities which do not dissolve in water. For example, sand, dust, mud, etc. Soluble impurities. Soluble impurities are the impurities which dissolve in water such as salt, sugar, chemicals, etc. Removal of impurities from water. Insoluble and soluble impurities are removed by different methods. Removing insoluble impurities. Insoluble impurities are removed by various methods like separation, filtration, sedimentation, and decantation, etc. Filtration. Fold a sheet of filter paper into half and then into quarters. It takes the shape of a cone when we open it. Place it in a funnel. Place the funnel with the conical filter paper inside the mouth of a bottle. Now, pour a mixture of sand water into the funnel. Clean water collects in the glass and insoluble impurities on the filter paper. This process of removing impurities through a filter that allows water to pass but not solid particles is called filtration. Sedimentation and decantation. Add some sand to a glass of water and stir it. Leave it for 15 minutes. Now, observe the glass carefully. You will see the sand particles settled at the bottom of the glass. The water above the sand particles is clean. The sand that settles down is called sediment, and the process is known as sedimentation. Now, pour the clean water into another glass slowly without disturbing the sediment. The sediments are separated from water. The process of pouring water is called decantation. Removing soluble impurities. Soluble impurities are removed by distillation, boiling, and chlorination, etc. Distillation. Methods of evaporation and condensation are used for removing soluble impurities from water. In this process, water having soluble impurities is heated till it becomes steam and then allowed this steam to condense in a condenser. This condensed water is free from impurities. We collect and use it. This process is known as distillation. The pure water obtained after distillation is known as distilled water. This is used in batteries and laboratories. Purifying drinking water. Water may contain germs and some soluble impurities that can cause diseases. Clean water is must for our good health. So, water can be purified to make it fit for our consumption by following different methods. Boiling. Boiling is the simplest method of purifying water. Boiling water for about 10 to 15 minutes kills the germs present in it and make it fit for drinking purpose. Chlorination. Another method of purifying water is chlorination. Adding chlorine tablets in water kills germs and make it fit for drinking purpose. Thus, these are very common methods of removing impurities from water. To make water obtained from lakes and rivers fit for drinking, it is purified in large purification plants before it is made available to homes.